Hello everyone, welcome to this module and lecture series on object storage. In the first module, we will introduce OCI object storage and look at some of its capabilities. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. So as we have been looking into this slide earlier, we have looked at the local storage, we have looked at the block storage, and in the next lecture series, we'll look at the file storage. Um, Object storage is the kind of storage architecture where you manage data as objects. This is in contrast to other storage architectures like file storage, where you manage data as a file hierarchy, and block storage, where you manage data as blocks within sectors and tracks on a disk. So that's the main difference between object storage and the other storage architectures. And there is you have different classes within object storage, and one of the classes is archive storage, and we'll look into more details on the archive storage as well. So what is object storage? Again, as we just saw in the previous slide, let me recap some of the key characteristics. It's internet scale high performance storage platform where you manage uh, data as objects. This is ideal for storing unlimited amount of unstructured data. And there's a huge explosion of unstructured data nowadays, whether it's images, media files, logs, backups, etc. Like I said, data is managed as objects, and you use APIs built on standard HTTP verbs like get object when you want to read an object from a bucket, put object when you want to write an object to a bucket, etc. This is very different than using NFS protocol which you would use with file system, where you are managing data in a file hierarchy, or iSCSI, which you would use in a block storage to access data as fixed size blocks on the disk side. So that's the main difference: data being managed as objects using standard HTTP verbs. It's Object storage is a regional service, and again, unlike the file storage and the block storage, you are not really tying this to compute instances. It's not like you mount this disk and you use it, or you use it as a disk to store your data and applications for your compute instances. There are two different distinct storage classes to address the need for performant frequently accessed hot storage, and there is also less frequently accessed cold storage, which is also called archive storage. So we'll talk about those. And you can have private access from Oracle Cloud Infrastructure Resources in a VCN using a concept called Service Gateway, which we looked into when we were discussing the VCN module. OCI Object Storage supports advanced features such as cross-region copy, pre-authenticated request, lifecycle rules, and multi-part upload, and we'll look into each of these in greater details subsequently. So what are some of the scenarios for object storage, right? Content repository is a big one, where you want to store a lot of unstructured data, whether it's images, logs, videos, etc. We looked into archive backup. Object storage seldom is used as a backup location. We saw this in the block volume module, where for block volumes, if you want to do backup, the backup actually is stored in OCI object storage. Object storage can also be used for long-term archival to reduce the cost. Uh, it's a good place to store your log data or large data sets, whether you are running any kind of DNA genome data or Internet of Things IoT data sets, where you have lots of data. You could store that in object storage. And again, you can read through a bunch of these big data scenarios, and we have connectors and so on and so forth, where object storage is a good candidate for those use cases. Now, what are some of the key features of the OCI object storage service? The first one is this concept of strong consistency. Strong consistency means that object storage service always serves the most recent copy of the data when retrieved. So what happens is, if you write a data and then you update that data, sometimes if your service, there's a concept called eventual consistency. If your service is based on that, and you try to you write a data and then you update it subsequently and you try to retrieve it, sometimes it will return the stale data. It will return the old copy, not the updated copy. Strong consistency means that it will not return you data unless it has committed it everywhere. And as you can imagine, these are distributed systems, so the data is actually written across multiple ADs. If it's a multi-AD region, in a single AD region, still written to multiple storage servers. So strong consistency means you are always guaranteed the most recent copy of the data, versus eventual consistency, where eventually your data might be consistent, might be the latest, but you might get stale data in between. As far as durability is concerned, like I said, data is stored redundantly across multiple storage server, across multiple ADs. If it's not multiple ADs, single AD, data is stored redundantly across fault domains. In case of fault domains, we only talk about compute and databases, but the storage services, some of the storage services also leverage that internally. So the data gets stored across multiple fault domains, so that even if one of the fault domains goes down, the other fault domains is still up and running. Um, Data integrity is actively monitored and corrupt data detected and auto repaired. So service takes care of that. So it's a highly durable service. So strong consistency, high durability, and also high performance. Compute and object storage services are co-located on the same fast network. So if your compute instances are reaching out to the to object storage, we guarantee strong a big fat pipe between them, so that they get very fast performance. And you have several features, like you can define your own metadata. There is server-side encryption, and we also allow you to bring your own keys if you want to encrypt data using your own keys. So let's look at some of the things in a little bit more detail. So first, we said data is managed as objects, right? So whether it's logs, videos, whatever, regardless of the content type, you manage all the data as objects. Now each object is composed of object itself and the metadata of the object, which describes what the object is, and has some more details, uh, things like identifier, etc. Bucket is a logical container for storing objects. So each storage is stored in a bucket. Namespace is a logical entity that serves as a top level container for all buckets and objects. So objects goes in buckets, and then buckets are placed in namespaces. Now each tenancy, when you create a tenancy, your account is provided one unique namespace that is global, spanning all compartments and regions. So it means you have one namespace which is global, but you can have bucket names which can be repeated across tenancies. So bucket names must be unique within your own tenancy, but can be repeated across tenancies, because the real unique identifier here is the namespace. Now this is different than, let's say, Amazon S3, where your bucket names have to be globally unique. In case of OCI, bucket names have to be unique within the tenancy, because the unique identifier here is the namespace, which is similar as your tenancy. Within a namespace, buckets and objects exist in flat hierarchy, but you can simulate a directory structure using prefixes and hierarchies, and we'll look into this in the next slide. So how do you name the objects? The service prepends the object storage namespace string and the bucket name to object name. So if you see right here, this is my namespace, which comes from my tenancy. This is my bucket name, and this is my object name, right? So this is how the service creates the object naming. So let's say if you have an object, database.dbf looks like a database backup file. You If you put that, you put object API, and you put this into the object storage, this is sort of the URL you would get, and this is how the object would be named. So you have the namespace here, you have the bucket here, and then you have the object here, right? This is the fully qualified domain name, or the fully qualified string, you if you will, which you need, right? So we talked about that the objects are stored in flat hierarchy. Now we are used to directory structures, where we store data according to directory structures and multi-directory structures, etc. So how does that happen in object storage? Because it's a flat hierarchy to begin with. So for large number of objects where you might have similar objects, you can use prefixes and hierarchies, right? So what do we mean by that? So if you look at this example here, there is a prefix at marathon, and there's another prefix which says marathon slash participants. So you actually get with with two different prefixes here. Now you can use CLI to perform bulk downloads and bulk delete of all objects at a specified level of the hierarchy without affecting objects in levels above or below. So what do I mean by that? So look into this example here. You can download or delete all objects at this level, at the marathon level, without downloading or deleting objects at the marathon participants level. So even though it looks like marathon participants is sort of a children uh, directory structure from marathon, you can still operate. If you create prefixes like these, you can operate at them independently, and you can have another object here which says start line and finish line and middle line, or etc, etc, right? And if you want to operate at all those objects as one, you could use the marathon prefix. If you want to have participants here, you have 100 participants and you have a bunch of those objects, you could operate at them using marathon slash participants prefix, right? So that's some of the ways you can operate on large number of objects, particularly because object storage itself doesn't have any kind of hierarchy. It's a flat hierarchy structure. So with that, let's just complete one more slide and we'll quickly jump into a demo. So we talked about the object storage tiers, right? So what are the tiers which OCI object storage supports today? So the first tier is the standard storage tier. It's also referred to sometimes as the hot tier. This is where you store your data and you get fast, immediate, and frequent access. You can retrieve your data instantaneously. Um, Always serves the most recent copy of data when retrieved. Why? Because we support strong consistency. That is the characteristic or definition of strong consistency. As we said, data retrieval is instantaneous. So you upload it, you download it, pretty instantaneous. Standard buckets cannot be changed. So once you create a bucket as standard, you have to keep it at the standard level. So there is another class which is called archive storage. People also refer to as the cold storage. This is for use cases or data where you seldom or rarely access data, but you have to retain them and preserve them for long periods of time. What are the use cases? This might be compliance. This might be your audit logs. This might just be long-term backup and retention, right? You have lots of data, you just want to retain them for a specific period of time. There is a minimum retention requirement of 90 days. If you restore your data before that, I think there is a cost which you have to incur, and you can look in pricing and see how that works. One restriction here is you cannot instantaneously retrieve data. Objects need to be restored before you can download them or retrieve them. The time to first bytes after archive storage restore request is made is 4 hours. So you upload the data, let's say 90 days have passed, you want to get it back, you make a request, it takes at least 4 hours before you can download the data. And like we saw with the standard tier, once you designate a bucket as archive bucket, you cannot upgrade to standard storage tier, and vice versa, right? Standard cannot be downgraded to archive, archive cannot be upgraded to standard. And right here you can see when you create a bucket, you get a choice of either standard tier or archive tier. So thank you for watching this lecture on a quick introduction to the OCI object storage service. In the next module, we will do a quick demo of the service and see some of its key characteristics in action. Thank you.